All right, hi. My name's Bill. I do front-end stuff for a computer security company. And my talk today is called Beyond Math.random. I'm going to talk about random numbers, where they're useful, where they kind of break down, and what you can substitute in place of them when they do break down. Cool. So if you flip a coin 100 times and it's heads 100 times in a row, and you flip it that 101st time, what are the odds that it's going to be heads? It's 50-50, right? And that's good for using stuff like making passwords or shuffling arrays, like cards. And that's what Math.random does. Every time you run it, it gives you a number that's basically, it's supposed to be completely independent of the number directly prior to it. And that's useful for passwords, but it's also extra useful for when you can't do something. Like if you have a whole grid of values and you need to know something about them, you can just sample a random number of them and get a good idea. Like if you need to know the brightness of an image, just sample 10% of the pixels and you're doing pretty good. And you see that all over the place, like in opinion polling or really big computer simulations. If they need to look at a whole big area on the weather map, they don't. They just pick random spots at a predefined interval. Random numbers are also really useful for simulating stuff or making stuff. Like you can simulate natural phenomena or like seemingly natural phenomena. Like an ant, like the direction an ant turns, or where a waterfall will, or a water drop will fall next, or like where a sprinkle will fall. The DonutJS website uses random numbers to. Hold on, I'm gonna drop this. Uses random numbers to put the sprinkles on the screen, and the reason that they do that is because they don't want to have to decide where the sprinkles should go, and they don't want to have to transfer that to your computer and have some code run and some state be checked every single frame. So like when they need to reset the position of a sprinkle, they just ask Math.random. So because JavaScript is really great, I can just patch in different functions for Math.random, and we can see what happens. So this is when it's just a quarter of the way across the screen. And that's okay. That's okay. And that would do. And let's say if it picked a random position every time you went to the page and just stuck with it. But you can also substitute a trig function. Like this is just, it just does the sign of the time, and it should sweep back and forth. And something that's cool about that is that you can tune the frequency of it. So if you want to have it sweep back and forth faster, it actually looks random now because the frequency is high enough. But you can also combine a bunch of different cosine and sine functions all together and make this really kind of complex waveform where it sweeps to the middle and then kind of stays there and sweeps back, and it doesn't really go the whole distance the whole time. Who made it so that the sprinkles fall at a random velocity? Was that? You messed me up. My demo didn't have, things don't fall at a random velocity, they fall at the same speed. So anyway, so I would have had a problem with that. Okay, and all the sprinkles are exactly far enough away so that they're the same size perceptually, except yeah. Okay, so that's where we're getting ahead of ourselves. So that's Math. This is the worst slide ever. That's Math.random. It's useful, but it breaks down. You can't zoom. It's not repeatable. Our Math.random in JavaScript doesn't have a seed function. So if you want the same random numbers every time, you can't do that. Zoom would be like if I wanted to go to this corner of the screen and get just those numbers in just that XY position. But it doesn't really work like that because you're asking for them like linearly. Also, because you can't just go to a coordinate, you can't really shift the coordinates. And stuff really isn't random. It's just not. It seems random, but it's actually just a whole bunch of different periodic things layered on top of each other that at high enough frequency appear to be random. So this is what most things are composed of, a bunch of sine waves. And this is better than Math.random because you can zoom in. It's repeatable. The sign of pi is always whatever that is. 1 or 0. You can shift it, and stuff actually is kind of sinusoidal. Like in physics, you can use sine and cosine and get real stuff. Like if you have that in your equation, you can still go to the moon. It doesn't break down. But the real next level stuff is invented by computer graphics people in the 80s. It's called noise, and it's like this picture was actually made with noise, where if you put in the x and y positions, you get just a scalar value out. And wherever that's useful, you can use noise to like get an enhanced amount of realism. This looks really realistic, but it actually kind of does. The water is actually fantastic. If it was moving, you wouldn't think twice about it, but you know, there's no marble rabbits. Okay, so this is a little bit more complex than noise or randomness. This is the code for Math.random in V8. And it's 3 lines, and there's 2 variables, and there's a bunch of bitwise stuff. But like the code for noise is 5 pages. And you need comments, and there's 3 functions, and you can do a bunch of different stuff. So let me show you. I'll do the demos here. We saw the box thing earlier. Cool. So this is 2D noise. And I'll show all the stuff that Math.random couldn't do. You can zoom in on this. You can, the size of the box is the value of the noise at the position in space that the box is in. And you can also, in this implementation of noise, you can add a 3rd dimension, which I'm making to be time. But I could draw more boxes and show this kind of like Minecrafty, you know, slithering glob world. But I'm just doing it in 2D and making the boxes get smaller and shorter. So let me turn time off. Yeah, so you can zoom in, you can shift it, and you can also squish it, which is really important. Here, let me zoom in and then squish it, and you can see. Yeah, so if you're looking for different effects, like, you know, if you want to make a donut and you want to place sprinkles or get the edge of that crease done, you would squish your noise in 1 dimension and displace your donut. We do something kind of like that. Actually, the next demo is using this same 2D noise field, except instead of making boxes bigger or smaller, it actually drives the positions of particles. And I wanted to compare particles that were driven by noise and as opposed to particles that are just driven kind of randomly. So these are 2 particle systems. The green one are influenced randomly at every step. Their velocity is pushed in a random direction, but the red ones are influenced by their noise space. And like wherever they are, they go, what's my noise value? And if it's like 6, actually there's 2, one for x and y, they'll always go in the same direction. And this is kind of a hard, I wanted to cut this slide because it's not really obvious, but you just kind of tell the red ones are better. And the green ones are all moving at the same speed, and the red ones, you can see there's kind of a, you know, it's a little smoother in terms of their aggregate velocity. And it's actually, yeah, cool. So what's the next one? Cool, this one has a video. So it's nice that first talk talked about ILM and Disney. This is one of their first, the outputs of that tool company is this kind of fractal noise generator for this, one of the first CGI, I'm glad the video's playing, the first CGI particle system in like a major movie that William Shatner would be in, and this is the first like zoom in terrain that wasn't painted by a person with like paint. And you can see how useful the noise generator here is because there's no way that they could have stored all this information in 1980 whatever, especially among all their different computers. Imagine if they just store a bunch, you know, $150,000 worth of texture maps, but instead they could just do 10 cents worth of processing at every pixel to figure out where the height would be. And you can see there's a bunch of different aspects of noise being layered all over in the clouds. Someone came in and drew a hurricane, but like it's a tool that you use. It like assists you in what you're trying to make. So we'll go ahead and make a terrain generator that's kind of like that. Cool. So instead of making boxes that are bigger and smaller, I use the noise value to set the height of a terrain. So here I'll show you. We just set the height separately. You can also zoom in. So this would be if you were really high up. And the cool thing is if your rocket, you know, is shooting down to the surface or whatever, now you can just zoom in. And that wasn't very computationally expensive. If you stored all that information, it would get out of hand really quickly, especially if you had to keep all of that around for months and months. You can shift your position. And you can also have the position just shift automatically, which is this really great effect. And it never really gets old to me. Cool. So there's that. Oh, yeah. So since it's a tool, basically all you're doing is you can see I'm like making a new thing run, and I'm changing some parameters. So if you want to make something like a piece of art, you just pick a bunch of parameters and then set your camera and kind of set your color. Like if I had an oceanjs.club or a surfjs.club, this would be on my website instead of a bunch of sprinkles coming down. And I would, if you sample your noise space in an increasing dimension, you can make it look like, you're traveling along the waves. It's a really, it's used everywhere. If you can, these days, a lot of the CGI movies have been doing like mirroring and kaleidoscope array effects, but at the most detailed on the surface, they're always doing a pass of noise like this, or multiple passes of noise like this. And I'll do that on a rock here in a second. Yeah, we can make the waves taller, or we can make them smoother, or we can make them roll in faster. Actually, I make them roll out faster. All right, cool. Rock thing, great. I'm glad we're doing good on time, because I wanted to show this one. It's really the most detailed. Cool, so you don't have to just make squares bigger, and you don't have to just set heights. Anytime that you have a scalar value, a one-dimensional value that you want to use, you can. So in this case, I'm setting the radius of all the vertexes, and I'm doing it on 2 passes of noise. The first one, here, let me turn the second one down. So the first one is, when you talk about noise, you kind of talk about octaves. The first root octave sets like the main deform on the rock, and then I do one more pass at a higher octave that sets kind of like a roughness on the rock. And let me change the intensity and set the level of detail to be higher. And what's really useful about this is if you're using this in your asset creation pipeline, if you set the parameters the same way and you set the noise seed the same way each time, you get the same rock each time. And that's really helpful because these models can get really, really big. And if you're building something that's procedurally generated, you need to know that, because there's going to be a house that goes on top of this rock, and the person who lives in the house doesn't want to be this giant gap when the 4th person runs the game. Anyway, cool. So let's take all that together and make something. One of my favorite bots, I didn't make this, is a bot called Wildflowers Bots, and it just tweets nice pictures of wildflowers. And you can kind of see, I don't know if they're using noise, but you can kind of see how they would use noise. They could pick the height of the edge of the hill, and they can, if some value of the noise is high enough, they'll place a flower there, and then they use a different noise field. And if that, meets a threshold, then they'll place some grass. And, there's just kind of endless variation. And I want to make my own kind of like Pacific Northwesty version of this. So I was able to, here, let me hit save. It takes a second on my laptop. Cool. So this is that rock, and I just hard-coded some parameters, and it's the same thing each time. So I use that terrain generator from earlier, and I place some trees based on one noise field, so like it calculates every tree step calculation. It goes, is the noise greater than 0.4? Well, then place a tree. And then, you get this kind of natural placement, and it's grouped in just the right way that you like it. And if it's not something that's usually grouped, you can increase the frequency, and then they can be more sparse. I actually did that with the height of the trees. I wanted them to be mostly even, but not sometimes. And when they were not sometimes, I wanted them to be really uneven, because that's kind of how it works. Like, they just cut trees down, and then there's like this line of really new trees and really old trees that one are much taller. Cool, yeah, that's it.